Hello guys, welcome to my YouTube channel Atmotex and my name is Kunal Singh. So let's start our today lecture that is based on graph data structures. As we completed our 12, this is the 12 chapter, 12 lecture and we completed just now 11 lectures. So as I wish that you all see my previous lectures so that any clarity remains, so it is clear in upcoming lectures. So let's start our today lecture, which is based on graph data structures, which is most important data structure because it is the part of our non-linear data structures. As we completed all the linear data structures, so let's start by taking a intro of graph data structure. So open with DSA folder that we created in our previous lectures. So I open it with a VS Code editor. I created a graph.java extension file for our new lecture. So let's start with the comments. So I basically explain you what is basically a graph data structures. A graph is a basically is a collection of nodes that is we can recall it anytime anywhere. So by it contains parameters like edge and vertices, so we consider it with vertices and edge functions. And also we can take an example to discuss the clarity of what is basically graph data structure. So let's take an example of Facebook. And as we open Facebook, we observe that it contains many things, that is profile, images, uploads and delete, like, comments, anything that we see in the Facebook. So we discuss that what is basically graph data structure. So graph is nothing other than it collected all the nodes, that is like your uploads, likes, comments to other user, and this is basically collects all the data and shows to the user for their better interface. So it is the basic example of like Facebook because it includes the algorithm of graph data structures. So I write the full definition of graph data structures for your reference of notes. So let's discuss about basic terminologies of graph data structures. So first of all, in this it includes the adjacency, and adjacency is of two types, that is adjacency matrix and adjacency list. We all discuss about various elements and parameters of adjacency matrix and list also. And now we move further forward by taking another example of terminologies, that is port and also path, and I write it for your better clarity and vision. So these are the terminologies of graph, that is adjacency. When what is basically adjacency is a vertex is said to be adjacent to another vertex if there is an edge connected to them. Vertices 2 and 3 are not adjacent because there are no edge between them. And also we discuss about path. A path is a sequence of edges that allow you to go from vertex A to vertex B is called a path. Like 0 to 1, 1 to 2 and 0 to 2 are the path from vertex 0 to vertex 2. Directed graphs, a graph in which an edge UV does not necessarily mean that there is an edge UV as well. The edges in such a graph are represented by arrows to show the direction of the edges. And let's discuss about the various application parts of graph. As I discussed you that adjacency, it is basically of two types, that is matrix, as well as it is also available in lists. So it helps in many ways, like matrix as you see in your mathematics, that is 2 cross 2 matrix and 3 cross 3 and any n cross m matrix. So it is basically representation of a adjacency matrix in graph data structure so that it can be recalled easily to the other node and by efficient way, because we take less variable and this reduces the time complexity and space complexity as per our requirements. So we move further forward by taking the our next topic, that is the various graphs operations, that is, these are the various graph operations. And the most common graph operations are: check if the element is present in the graph or not; graph traversal, that is, going to one node to another node by a quick way, continuously. And traversal is something called, we discussed in our previous lectures, that is, traverse is basically move from one node to another, and nothing other than this is. And add elements, that is vertex and edge, to the graph, and finding the path from one vertex to another. So this is the basic intro of graph data structure. So let's discuss about what is the coding to execute, what is the basic elements and the parameters that we input in our coding, so that we use every code to execute very efficiently and know the better understanding of graph data structure. So let's discuss about by importing our java.util.star, and in this we create a graph class that is of graph, and use curly braces in it. And now we make a private, then we use map in this. As I describe you that one of the basic and main advantages of graph data structure that is also used in the mapping, that is Google Maps and also other navigation applications also, because it uses various uh, exciting pathways for reaching one node to another node, so that implementation of these code become very smoothly and efficiently for reaching our desired destination by making shortcuts of various parameters. So it is also useful in making navigation applications. So this is one of the application of this one also. And now use integer in this way, and use adjacency list, and now use public graph, then blank parenthesis, then use curly braces again, and this we use this for simply indicating one thing, that is adjacency. And then use list, and now we use new as our previous knowledge. So we use a map in this way, and now use blank parenthesis in it, and then execute our line. And now it's time to move further, that by using public void, and then use add vertex, and use integer and vertex, and then curly braces again, and then use adjacency, and now use a list in it, and then dot put vertex new array, and then list, and this one, and blank parenthesis in it, and now execute in this way. These all errors are shown in this are removed by making all other codes, because some parameters are not allotted their initial value. So when we initialize the elements value, so all errors are removed. So not afraid about that. So we use public again, and then use void, and now add edge in it, and use parenthesis integer source, and use again integer, and then use destination, and then use curly braces again, and then we use if statement, then use adjacency list dot contains and use again if statement samely as we use adjacency list dot contains key, then use destination, then use vertex and use destination for allotting the values of our add vertex that we use to adding a node in it simply way. So I use adjacency again because it is the main element of that is shown by our input list of Java. So it is also a built-in function in Java as we import so that it can recall easily. Otherwise we use our code in this a scratch mode, then use destination and then again adjacency list.get. It is simply as you run again and again so you understand the better clear vision of this overall graph, but this is the most important as it is asked by many top recruiters, so not to skip this topics because this graph data structure is most important. And now we move further forward by using our boolean data types. So I come in and use boolean public boolean and use has vertex and then use integer and use vertex in it. Now use again curly braces and then use return adjacency list and dot contains key vertex, then again use public boolean has, and this time we use to add edge and allotted a value of integer, then source again integer, then destination that we created earlier in our public class return and then add adjacency and then use list dot contains key and use source and use double ampere and again use adjacency list dot get and then use source and then use contains destination. So we use DFS in it and DFS is depth first search. So in this parameter I use public void def first search integer start vertex and we set a value of integer in it and then we visit it again and again of our overall hash set and then use DFS helper start vertex visited and we created a public void DFS helper in it because we initialize the value of full private void and we use visited dot add vertex and we use for loop conditions, and in this way we use the main boilerplate of our class that is public static void main string args and we use graph is equals to new graph and now it's time to import the vertex values, that is 1 2 3. And now we used to add adds in it, that is source, that is 1, and destiny is 2. And now source 2 is destiny is 3. And now it's time to retrieve our overall graph, that is a system.out.println, that is vertices graph dot adjacent list key set. And now we use edges to print out the elements. And now we use integer start vertex is equals to 1, and then we use to dfs starting from vertex. Dfs full forms, that is depth first search. And now we use to start vertex and then semicolon. And now it's time to retrieve in this way graph.dfs start vertex. And now it's time to execute our whole code in our Java terminal box. And now see guys, this shows vertex is equals to 1 2 3, that we given the value of 1 2 3 in it. And now edges are 1 goes for 2, and 2 goes for 1 and 3, and 3 goes for 2. And this way this shows bracketed, because I shows that adjacency is used simply as matrix type format. And now dfs is starting from vertex 1, that is 1 2 and 3. And this is the overall whole code of graph data structures. And so now it's time to conclude our today lecture, and more interesting lectures are pending. So stay tuned with my YouTube channel, subscribe my YouTube channel, subscribe with your friends, like it, comment it, and thank you for your love. Bye.